it will collect the data from the EHR, and then the backend services app then will manipulate the data. For example, if you need to de-identify or pseudonymize or anonymize the data, then it would use what is called as the data and the trust services actor to do that. And once that is done, the backend services app would then essentially send the data to the PHA or the research organization directly or through a trusted third party. So that's kind of a very high level view of the actors and systems. But in order to actually model all the three different use cases for public health and then generalize that, we have created a list of workflows, which I'll walk through on the reference implementation guide. So I'll share my screen now and jump over to the reference architecture implementation guide. Hopefully everyone can see my screen. Okay, so I'm on the reference architecture implementation guide. And the implementation guide is a standard FHIR implementation guide that many of you or most of you may be familiar with already. Has the same format in terms of the home page and then a table of contents, background sections, which has an idea of gives you an overview of the implementation guide and the use cases and workflows, and then the specification page, which gives you an overview of the various formal specifications. And then, of course, the FHIR artifacts, which includes all the different FHIR profiles and value sets and so on and so forth. So first, I'll jump into the implementation guide overview, and then after that, I'll take you through the other parts of the implementation guide. So one of the things that, like Maria said, this is a reference architecture implementation guide, meaning that this is a framework and an architecture, not necessarily, focused on the content, but focused more on all the components that are required for the multiple use cases. So we call this the reference architecture implementation guide. So we have a diagram in here. In this page, we kind of explain what this implementation guide is about. But then we have a section here which talks about the implementation guides and the relationships. I'll just jump to the library to kind of to the diagram to explain what we're trying to do here. So we have many basic FHIR capabilities that most of you are aware of, which is the basic FHIR framework, the Smart on FHIR framework, Smart on FHIR backend services, bulk data implementation guide, and many other things that are part of the core FHIR capabilities that can be leveraged to create an implementation guide. So we are planning to, we are leveraging these basic FHIR capabilities and putting together this MedMorph reference architecture implementation guide, which is shown in this third box here. And that basically is trying to build the common framework, common reporting framework for multiple use cases. There is another implementation guide in the public health area, also called as the electronic case reporting implementation guide, that also does certain use cases for the electronic case reporting domain. And so that implementation guide also has certain architecture components and certain content-oriented information. So these two implementation guides have components. So we are harmonizing these two implementation guides to make sure they're not conflicting or contradicting with each other, and create a set of architecture implementation guides. Now, these architecture implementation guides eventually will use the basic FHIR capabilities and any other foundational implementation guides that are available. Right now, we are leveraging the US core implementation guide, like many other initiatives do. So that will be there for the content purposes. Along the way, both MedMorph and electronic case reporting have identified a number of common public health reporting profiles that are going to be used widely across many use cases in public health. So there is the effort to create what is called as the US Public Health Library, Profiles Library, which will have a set of profiles that is common for most of the public health use cases. And that is shown in yellow here in the foundational IG sections. So the idea being that we define these architecture components and the architecture IGs, but then eventually we have to operationalize this with what is called as the content implementation guides, which is the fourth layer here that we are shown. And in the content implementation guides, you will see that there is an implementation guide being developed for cancer reporting, an implementation guide being developed for the healthcare survey implementation guide. And then for the Hep C use case that we talked about, the electronic case reporting implementation guide already has the content profiles defined. So we're going to reuse that for that specific use case. So the idea being that, once the reference architecture is there and is implemented, you can basically add new use cases with new content IGs, which would amount to just changing the content that is going to be reported for each use case, but the overall architecture will remain the same. So that's the purpose and the idea of this. So we thought we'll just present this to all of you to know, as we go forward, we'll be adding more content IGs in the future based on the reference architecture. So that's one of the important aspects in this IG. There's a few other pieces of information that are also important. So you can go back to the public health use cases and workflows. So this is talking about all the different business needs and other things that Maria outlined already. So I'll directly jump to what are the different workflows in MedMorph and how we intend to model and use the architecture. So the MedMorph workflows are essentially interactions between all the systems and actors that we already discussed. So I'll just discuss the workflow one by one. The first workflow we call as the provisioning workflow. The provisioning workflow is all about getting the systems ready for collecting data from the healthcare organizations and so on. So in order to do that, a public health agency or a research organization defines what is called as a knowledge artifact. And those knowledge artifacts will have trigger codes, as we call them. Trigger codes are essentially codes upon which we'll have to do reporting. So for example, for cancer reporting, you might be looking for a specific cancer condition. For electronic case reporting, you might be looking for a specific lab result or a lab test that has been ordered. So there will be different types of trigger codes. These are essentially codes from vocabularies that are appropriate, based upon which you would report. Then you'll also have timing parameters. For example, once the encounter starts, you might want to report for certain conditions. Sometimes you want to report when the encounter closes and is signed off. Sometimes you want to wait for a day after the encounter is closed and then report. So all of those types of timing constraints are kind of defined in this knowledge artifact. And then, the actual structures. The structures is essentially the content IGs. What are the structure definitions that you need to use for reporting? So the knowledge artifact will specify, the types of output that you need to provide or create and send out to the public health agency. So those structure definitions will vary based on content IG, but the knowledge artifact itself is capable of handling those, and then any software built to process a knowledge artifact and create the necessary output should be able to create the necessary structure definitions. So in this, the sequence of event that happens here is outlined as P1, P2, P3, and P4. In step P1, the public health agency is defining the knowledge artifact and depositing it in this publicly hosted knowledge artifact repository. A backend service app or an EHR. EHRs can implement all this functionality natively, but in our systems and diagrams, we have shown the backend service app being external to the EHR and implementing it so that we don't increase the burden on the EHR vendors to start with. And also it is a pluggable component that can live on top of the EHR as a module using FHIR APIs. So the backend service app, it's called as a backend service app, similar to like the SmartThumb FHIR backend services, because we're dealing with system to system interaction. There is no human in the loop. So that's the reason why we have termed it the backend service app. So the backend service app queries the knowledge artifact repository or gets notified whenever there is a new knowledge artifact of interest. And then it would download the knowledge artifact in step P2 and P3, and then process the knowledge artifact. Once it processes the knowledge artifact, the very first thing that it does is essentially takes a look at all the trigger events that are going to trigger different reporting conditions or reporting workflows, and then subscribes to those events with the EHR. So the backend service app would be creating those subscription topics that are necessary for it to report to the various public health agencies. So I know subscriptions is changing, going through a lot of change, and of course the R5 version has all the new stuff included in it, and the backport subscription backport version for release 4 is what we are planning to use. This is a release 4 based implementation guide, so we are planning to use the subscription R5 backport IG, and then use the subscription mechanism. So as we go forward, the hope is that subscriptions become more widely available in the EHRs, and we would be piggybacking on those subscriptions to do whatever reporting needs to be done. So this is the provisioning workflow. And once the provisioning workflow is done, the next workflow that would happen is the notification workflow. The notification workflow is essentially, once the provider is performing the care delivery operations, they would be updating the EHR based on whatever is happening in the clinical workflow, and data gets modified or updated or created in the EHR. As data gets created, the backend service app would get notified based on the subscriptions that it has. And that is where the processing notification happens. So the sequence of events here is N1, N2, N3, N4. N1 is essentially the provider performing their job as they regularly do without any changes. N2 is the EHR notifying the backend service app about changes in the patient record based on the subscriptions that were created. N3 and N4 as essentially interactions from the backend service app back into the EHR to retrieve the data that is necessary for it to perform the next set of actions. So N3 is going to be running certain queries and get some data back. So we are planning to use US core APIs for the most part initially for getting all the data out. Then eventually, as the use cases get more and more defined for the content IGs, there might be other data elements that will get added that would have to be supported by the EHR to retrieve. So based on the data that you retrieve and based on the knowledge artifact that was defined, then the backend service app starts processing the data to figure out what it needs to do next. So that's where the notification workflow ends. The next workflow is the report creation workflow. And the report creation workflow essentially is about creating the report and being able to get the report ready for submission. So it picks up from where notification stops, which is essentially the step D1 here, and then it will go through the sequence of steps here. The notification is done. After the notification is done, the backend service app in D21, D3 queries the data from the EHR that it needs to create the report based on the content profiles and the structure definitions that it needs. Once the data is retrieved, then if the data depending on the use case, a particular use case may require the actual de-identification, anonymization, or pseudonymization, or other types of hashing things before the data gets submitted. So in case of those requirements, it would invoke steps D5 and D6, which is essentially invoking a function to de-identify the data and then get the data back in D6. And then if there is further processing, it will do that in D7 and get the data ready for reporting. So that's the report creation workflow. So this is all about taking the data and massaging the data to do this necessary thing. The last piece, the last two workflows, one of them is called the data submission workflow. So after the report is created, the backend service app would essentially send the data directly through to the public health agency, research organization, depending on the authorities and policies that are present. So different use cases have different requirements. Some use cases will have a trusted third party through which the data has to come through. Some use cases will require the data to be reported directly to their organization. So depending on that, the backend service app would be doing that. And again, that is specified as part of the knowledge artifact. So the interaction is S1, S2, and S3. S1 is the finishing of the report creation. S2 is the backend service app, depending on the knowledge artifact, finding out the routing information that it needs, and then uses the routing information to send it to a TTP or a public health agency. So once this data makes it to the public health agency, then the last workflow kicks in. The last workflow is the response workflow that comes back. So the response workflow gets initiated on the PHA side here, in the where after the data is consumed and analyzed, there might be follow-on things that they want to submit back to the healthcare organization. In which case they would craft a response, and that response would be sent back from the PHA to the backend service app directly or through the trusted third party. So both of those models are supported. And then once the data reaches the backend service app, it might have to go back and re-identify the data in certain use cases. So you'll use the data trust services to re-identify. In some cases that might not be required, but you would deposit the data into the EHR if required, where the provider has to take certain actions. So these are essentially the various workflows for the reporting use cases. And we have modeled the various profiles and value sets and everything to make this generalizable. So that is part of the implementation guide. So before we jump in there to the actual FHIR artifacts, I wanted to share a couple of other things. So there is the formal specification that is outlined here, the public health reporting specification. So in the public health reporting specification, we have outlined all of the different pieces of information. Of course, we're using the Smart on FHIR backend services authorization for all of the system to system interactions. And one of the critical things is the knowledge artifact and how it is defined. So I'll spend a few more minutes on that before I jump into the FHIR artifacts. The knowledge artifact, which is a core component and is one of the important things that kind of ties everything together, is essentially defined using the FHIR plan definition resource. And it is based on the event condition action rules in computer science. So essentially, you can think of it as workflow activities result in events, and based on that, notification happens. That is the event notification, and the event notification will come with a context, and that context will be used to evaluate certain conditions. If the conditions are met, you perform certain action. If the conditions are not met, then you would terminate the processing. So we, for example, if you are looking at a cancer reporting example, new diagnosis could be entered in the EHR by a practitioner for a patient. So a notification of new diagnosis comes in, and then you would evaluate if the patient has the cancer diagnosis based on the trigger codes. And if it is, then you might report the data to cancer or the public health agency. Or you could alternately just terminate the processing if the patient does not have the cancer diagnosis code. Similarly, for a healthcare survey, a patient encounter was closed out by a practitioner, and that practitioner is registered to be part of a healthcare survey. So whenever the encounter closes notification comes out, then you would check if the practitioner is enrolled for the healthcare survey. If they're part of it, then you would report the data to NHCS and then terminate the processing. So in order to do this, what we have defined is the knowledge artifact. The knowledge artifact components, essentially it's a bundle which contains a plan definition and a bunch of other things. The plan definition will contain the events, the conditions, and actions, which it is capable of already. Then there is some metadata. Then there will be value sets, which are essentially trigger codes and other types of codes that are used. There is a library module that you can include, which includes logic for using either SQL or FHIR-path, depending on what you're using. It would also specify the endpoints of where the report needs to be sent out, and then certain security aspects, which includes de-identifying and all the data trust services, and also if you want to encrypt or decrypt the data while sending. So all of these are defined, and we kind of go through on how to define these knowledge artifacts. So the idea is every content implementation guide and every use case will define a specific knowledge artifact, one or more for their use case. And those knowledge artifacts will reuse all the different pieces that are defined in this reference architecture IG. So I will jump over. I have, I think, 5 more minutes before we take questions. So jump over to FHIR artifacts and show some of the important things here. We have capability statements for all of the actors, each of the actors in the MedMorph IG. So you can refer to that and see what is required to be supported. But more importantly, I think some of the things that are important to understand is the public health trigger definition named event. So we're trying to create a US public health library, like I spoke about. One of the important aspects of that library is this public health named event library. So this is essentially all of the events that can happen in an EHR workflow that are relevant to public health. So for example, encounter start, encounter close, modification of encounter data, new diagnosis or a modified diagnosis, uh, new medication, new lab results, new orders, and so on and so forth. We call this as named events. These are used in the plan definition knowledge artifact to define when a particular workflow is supposed to be triggered. So the idea is there will be a subscription topic defined by the IG for as we finish ballot reconciliation for each one of these things. So those subscription topics is essentially what we would be using to subscribe to the EHR to get notified. And depending on the use case, you'll pick one or two or more of these named events. So like, for example, cancer reporting might be only interested in the encounter close. Healthcare survey might be interested in encounter close, whereas a hepatitis C might be interested in an encounter start and a lab result change. So depending on the use case, you will pick kind of from the menu of the named events that you want to subscribe to, upon which the actions will be triggered. So this is an important value set that is being vetted and going through the ballot reconciliation process. Another important value set is the actions that you're going to perform once those things are triggered. So this could be initiating the reporting workflow, executing the reporting workflow. And when you're executing the reporting workflow, you can do checking of the trigger codes is one aspect, checking participant registrations, creating the report, validating the report, submitting the report, de-identify. So we are kind of defined an action for each one of these things, meaning that when a particular event happens, you can use this menu to figure out which action you want to execute. And based on the action, each action here is will have well-defined semantics that you would basically require to be performing, and then eventually terminating the workflow. So that is two important value sets that I thought I will highlight. Then there is, of course, the plan definition profiles and other profiles that we're using. We are using a content bundle and a reporting bundle and a specification bundle. The specification bundle is used for creating the knowledge artifact. It's a simple bundle which can have pretty much all the different pieces that it needs, including the plan definition, value set, and so on. So there is profiles for generalized profiles for the specification, generalized profiles for reporting, sending out the actual content, and so on. So again, this is the architecture IG. So that's why we're defining this in a generic way. The content IGs will reuse this and layer in more constraints and additional constraints. Now, in terms of the reference implementation, we talked about before, electronic case reporting has been doing a lot of good work over the last few years. And we are kind of harmonizing and piggybacking on many of the electronic case reporting work. So the reference implementation for this is in the GitHub right now. It is in the repository called Electronic Case Reporting Now application. So as part of that, we have added a lot of the functionality that is required for the MedMorph use case. And within the MedMorph use case, if you go in there, you'll see that there is a lot of work that has been done on the backend service app itself. And the backend service app will have like the knowledge artifact processor and so on and so forth. So anyway, that is for people who want to play with the code, download the code and start working. Again, it is an evolving implementation. So I'll stop there. I think we have about 10 minutes left for questions and answers. So we'll be more than happy to answer any questions and answers.
And Dragon, I do see I see one question in the Q&A in Whova. It is, are you storing any of the data in the backend app?
So the backend app is not intended to store any data. It is supposed to execute in kind of a stateless manner based on the trigger events, collect the data necessary, and then send out the data to the public health agency. Now, that is the theory. On the practical side, the backend service app is supposed to be residing within the healthcare organization. And since it is part of the healthcare organization's footprint or the ecosystem, it will be capable of storing certain data. So for example, what report was sent out for what patient at what time. And then what response was received for the message that was sent out, and when was the message received, and what processing was done. So, there will be, I would say, it is capable of executing without storing the data, but in more practical, on a practical note, it will be definitely storing certain data that is necessary for auditing and tracking and essentially, managing the application. And since it's part of the healthcare organization footprint, we assume that there wouldn't be any issues in terms of the authorities and policies that would prevent it from doing those minimum necessary functions.
Okay. All right. I do not see any other questions at this time. Did you have anything else? I know you're interested in the time for Q&A. Did you have anything else that you'd like to present until the ending time here, Dragan?
Yes. I think Maria will take over and talk about the value of MedMorph and where we are headed. So I think I'll stop and I'll let Maria share her screen.
Okay, fantastic.
All right. Yeah, so whoops, it started over again. So really just to kind of tie everything together that we talked about, we'll tell you a little bit about the value of this MedMorph approach if you weren't able to gather it already from what Dragan described. So really we're looking at a way to standardize across EHRs, institutions, and so forth, so that the implementation is more consistent and can be more portable between sites or platforms. So for example, if it's a healthcare system that transitions between systems, so they maybe get a new EHR system, there is onboarding of more sites for any particular type of reporting or research project. And in this way that we have a consistent description of how to leverage EHR FHIR implementations for data exchange between those EHRs and an endpoint. So for example, public health surveillance systems and data marts. And so you can kind of think about it as the EHR being kind of a car, the FHIR APIs, which are the EHR FHIR implementations we were primarily talking about, being the gas pump with the data being the fuel, and this implementation guide essentially being kind of like your GPS. And as we, in the future, maybe add more types of data or data systems that are sources, you can add more types of vehicles and so on and so forth. So this is really something that you would kind of need all of these different parts and pieces together to really be able to do this in a more standard way with a common architecture across systems and organizations. And so what we're talking about really is going from what tends to be the current approach of multiple different methods and approaches, and this sort of spaghetti-like intersection of different roads, to something that's a lot more common and streamlined through the use of FHIR, and just really bringing a lot of what's out there together into this common architecture and filling in any gaps. And that kind of constitutes the rest of the concept behind this reference architecture. Any more questions at this point? This is our team in case anybody's curious.
And I'm not seeing any more questions here, Maria.
Okay.
So if you guys are all set, I'll go ahead and, oh, I saw, I see one more that's coming in. It looks like someone's typing.
Okay.
We'll give them just a minute here. All right. The question is, what does this mean for public health agencies? What should they be doing to prepare?
So in general, it will allow them to also leverage this FHIR standard. It is something that through a series of regulations, I'm sure has been on their horizon or on their radar. And so preparing by learning more about FHIR, implementing FHIR systems. I know CR, as we mentioned, already has a FHIR implementation guide. So eventually transitioning to FHIR would really help use what we've developed a lot more readily. And honestly, because we're creating this in kind of a common architecture, it should be once they've sort of set it up, the differences will just be in the content, as Dragan described earlier. The architecture will remain the same, so it allows for kind of a little bit more of a plug and play with respect to the content and being able to accept more of it just using the same architecture. Did that answer the question?
I believe it did. I believe it did. Yep. And yep, he is confirmed. Yep.
Great.
I don't see any more questions at this time. So I will extend. I know we have just a few minutes left here. If there are questions after this, please do put them in the chat, and we'll make sure that that's relayed to the two speakers today, and we'll make sure that those questions do get answered. So thank you so much, Maria and Dragan, for the fantastic presentation. And thank you all for joining. This will conclude the MedMorph presentation. Thank you so much.
Thank you.